Okay, we're live.
Sweet.
Um, so let's go ahead and go over to or do you want to go over the final project stuff first?
Yeah, we should talk about that real quick.
Okay, because that's one of the things that we're supposed to do today, actually.
We just got to decide who like the main writer is or whatever. I pulled up the document
Well,
for it, but I don't
right.
even what?
Well, different people are supposed to do different parts. So, like
Right.
step one, basically we have different people for steps one, three, four, five, and six.
Mhm.
Um, and then step two and step seven, everybody do.
Mhm.
And so the first one, we need somebody to design the study, and then somebody to describe the data, make inferences, and then take action. But one cool thing that it notes in here, it says, like, for example, if you're in charge of describe the data, you could ask one of your group members to create and label the charts and then send them to you to be graphed into the main document. So
Mhm.
you might be writing up like a short little essay describing the data, but then you could ask somebody else and be like, hey, I don't have a ton of time. Can you make some charts to throw in there? And then just put the charts in there when you can.
Oh, okay.
So we can there's like one person that compiles everything, but you can ask for help with the different parts.
Oh, okay. Okay, that makes sense.
Um, we are also supposed to. So please collaborate together on each step. Um, so basically, like everything is due at the end of the week on Saturdays, like the rest of our assignments.
Mhm.
So it's something that should be done probably by like Friday at the latest, and then give people Saturday to look at it and go over it, say what they think, and then submit them.
Mhm.
So I know Tyler, you said you're pretty busy this week. Um,
Yeah, I've got some huge projects due this week. I don't even know what happened. It just like collapsed on me.
I can do the designing the study part. I've got tomorrow or Thursday off work that I can spend working on it,
Oh, nice.
and so I can take that part. And I know we're supposed to. Are we supposed to write in each of the persons and then send it to Mrs. or to Sister Cook? I think
Oh, okay. Have you opened this little document that is this thing?
that's what.
Have you opened up the little design study attachment?
Yeah, I looked at that the other day.
Yeah, it doesn't look too bad.
No, it kind of walks you through all the steps. The one thing that
Yeah, it
I'm
looks
kind
pretty
of
good.
concerned and somewhat confused about is like the actual study, like deciding what we actually want to do for a study.
Yeah,
Um,
and even on
because
there, there's a list of a bunch of things that we can choose to study.
yeah, but some of them just sound absolutely awful.
Yeah, that's true.
Like which one? There's one that's like compare the word count of the New York Times, estimate and compare the average word per sentence in the New York Times and in a local newspaper. That sounds miserable. And let's count out the first 100 sentences of three newspapers and the New York Times. Yeah.
That's true. That would stink.
Um, and then go to the local cemetery, and that one just sounds creepy.
Yeah, that's true.
Um,
Out of all births, is the proportion of males equal to 0.5?
that one's one I think is interesting.
Are there 1,000 chips in every bag of Chips Ahoy? Are brand A paper towels stronger than brand B?
Chips Ahoy are a cookie, not a chip, though.
Yeah, that one's kind of confusing.
There's not going to be 1,000 chips because it's a cookie. There's like 30.
Is there a difference in that? So all we need to do just to get the project rolling, we just need to come up with a study that we'll come up with a study, and that's gonna pretty much decide what we do the rest of the time, huh?
Pretty much. Like, if we decide to do, like, so let's say our brand A paper towel is stronger than brand B. Well, we need to figure out a way to test that. And we need to decide on two brands. So we could say, let's use, we sell Viva and Bounty at Walgreens. So Viva, let's say we're supposing that Viva brand is stronger than Bounty brand. And then our test could be, okay, we've got a spritzer bottle and 3 quarters. We're going to spray the quarters twice and then spray them 3 times on top of the paper towels and then lift the paper towel and see how long it takes for it to break. And then go through and do that like 30 times with each brand. Studies are really tedious.
Oh, you know, it'd be a good one, and I think it'd be kind of simple.
What?
We should do which is drink, like, between our samples, like, which is more popular between Coke and Pepsi.
That would be really easy.
So we could just ask people, like, we could just go around, ask a ton of people, get like 30 subjects or whatever.
I could do it at work and just like keep a tally in my pocket and be like up to random customers and get I don't even know how many people.
That would be perfect.
Yeah, I work at Jimmy John's too, so I can do that also.
Oh, perfect.
See, we could just say like every 10 people that pass us, we're gonna ask.
Yeah. Oh yeah, we could do a systematic one.
Mhm.
That'd be so cool.
Except we don't have Pepsi at work.
Oh.
Well, do some people go to your job and then never get a drink because they absolutely hate Coke products?
Yeah.
See? It could happen.
Okay.
So is that what you guys want to do? See which one is more popular?
So, like, we could state we would have an alternative and then a null.
Right.
We could
Well,
claim that, like, Pepsi is more popular in today's day and age or something.
right. Just kind of among our group, which ones do you guys prefer? Pepsi products or Coke products?
Coke.
Yeah.
What's the difference? Like, I don't even know. I never really like. So, like, what type of product would be under Pepsi and what would be under Coke?
It's really
Pepsi
opinion
products
based.
include Mountain Dew, Pepsi, Diet Pepsi.
Sprite.
No Sprite. Oh, dang it, no.
Wait, are you talking about Coke products or?
Pepsi. We're listing off Pepsi.
Oh, never mind.
Sierra
Sprite's
Mist is
under Coke.
Pepsi. Coke products are Dr. Pepper, Coke, Sprite.
Pepsi, root beer.
Well, root beer depends on the root beer, because some root beer doesn't fall under either one.
Oh, are we gonna do all of those drinks or just Coke versus Pepsi?
Oh, you just want to keep it simple? I was thinking like Pepsi product versus Coke product.
Oh, I don't care. I think it would
Some
be.
people don't like cola or caffeinated beverages, but
Yeah,
absolutely love their Sierra Mist or Sprite.
that's true.
And
That's
some,
true.
like, I don't like dark colas necessarily, like the Pepsi Cokes, but I love Mountain Dew.
That's true. So I guess it's just as simple because you find out which one they like better, and then it's either
Or
Coke or
group.
Pepsi products.
Well, and so my question is, like, what would our null hypothesis be? Because, is that part of it for this?
How about the null hypothesis is what we agree amongst ourselves. I guess if you guys have some roommates here, you could ask them so we could get a little number behind us. So,
Yeah, we could just use from even just our group and then some roommates. I agree with that.
Okay, that's what I was thinking. So, Tyler and Naomi, you guys both like Coke products.
Mhm.
Yeah.
I like Pepsi. What about you, Joe?
Joe, you're deciding.
I'm kind of mixed, honestly. I mean, I can't. I honestly don't mix. I like Mountain Dew and I like Sprite, and that's about all I drink.
Which one's your favorite out of those?
I'd probably have to go with Sprite, I guess.
Is Sprite Coke products?
Yes.
Yeah.
I don't know.
Perfect.
So more people like Coke products
In our group, yeah.
in our group, yeah.
So that we could use that as our alternative in null, I would say.
Right. Well, and so we can say our null hypothesis is that more people on average like Coke products, and then our alternative would be that the two are, well, okay, it wouldn't be that the two are not equal. Dang it, that's going to be a hard one because that's going to be more qualitative than quantitative data, isn't it?
What do you mean?
Well, like this chapter that we're just going to be talking about, kind of discussed that when you're doing qualitative studies,
Mm-hmm.
you do some of your calculations a little bit differently. So, like, which one is better is a matter of opinion. There's no way for us to actually go through and say, mathematically, Pepsi products are superior to Coke products. It's going to be based off what people like, what people drank when they were growing up, what their parents bought type of stuff.
That's true.
And so I just remember that some of the formulas that we use are different because of that.
That's true.
So we can still do it. It'll just be worded differently than what we've been working on. So everything that we've done up to this point has been quantitative, not qualitative.
Yeah. So couldn't we still say, so right now, because our alternative hypothesis could be just that Pepsi products are greater, and then it would just be a one-tailed test, or are we going to have to do a two-tailed test?
Well, because we're seeing that Coke products are superior already, so that eliminates that they could be
Equal.
Well, no, less than. So I'm thinking, what if we were to
Oh,
so
right.
that it was greater than or equal to? Are
What's
we allowed
that?
to do that? Make it so it's one-tailed, but it's greater than or equal to.
Okay.
So I mean, if we go through and we find out that the average student, or like out of all the people, on average, 50.56% of people like Coke product, and 49 point whatever like Coke, or yeah, whatever I just said, Pepsi Coke. That's pretty well 50-50 in my opinion.
That's true. I agree with that.
So that'll just be one thing to look at and say, like, okay, it's not true that they use that. And so because of that also, when we describe the data, there are some different charts that we could use. Since we're only looking at two products, we probably don't want to use a pie chart.
Mm-hmm.
But
Maybe
we can use these bar charts.
Yeah, bar charts would be good. Okay.
It's okay.
So,
Cool.
sweet.
I'm trying to see if I can make that less than or equal to. Oh, I can.
Sweet. So we've got our research question. The population we're studying is probably going to be mostly from you at work, right, Dylan?
Well, Naomi at work, me at work, and the collecting the data is something that we all have to do.
Oh, that's right. That's right. I forgot about that.
Yeah, so we could make it just like over the course of the week, make sure that you talk to. Do you want to say each of us gathers 45, like samples from 45 people?
Yeah, that would be sweet.
so
Okay.
each of us 45 people.
Yeah. Well, and that's something. Yeah, that would be part of describing the day. So 1 second, let me start typing this up so I can remember it.
Are you writing it? Are you gonna turn it in?
Yeah, I'm gonna
Or
do
be
the
the-
design the
the
study
first part?
of this.
Okay.
So then, which sampling method will your group use? Describe in specific detail how your group will collect data using the sampling method. Where do you think the sampling method described in the questions? accurate representation of your population. Ooh, that's pretty cool. Each group member sign below that you will not collect data until your project has been approved in writing by your... Ooh, we have to sign that. Whoa, interesting. Hey, this write-up's really not all that bad.
I think all of the write-ups will be like this too, where basically
This is short and
steps.
simple.
Yeah, that's not bad at all. That's sweet.
Yeah, well, and so this is like, I don't think we'll have to worry about like number 7 here, because that's kind of hard to do with you guys in Rexburg and me here, and then Sister Cook being over in this area as well.
Yeah.
But you know, we can all, or I can send an email saying, hey, we talked about this, and we all agree with what we have listed here as our study, and then she would be able to give us our approval for us to go forward.
Yeah. Yeah, that's sweet.
Awesome. Sounds good.
Alrighty. So anything else we need to do on that, do you think?
Oh,
Oh.
1 second. So I just want to hear what you guys think while I've got you here still. So for our null hypothesis, Coke products are liked by more people than Pepsi products. You know, for our group, that's true.
Mm-hmm.
Our alternative hypothesis being Pepsi products are liked by more people or an equal amount of people than Coke products.
Solid. Can we do a test like that where it's either greater or greater than or equal
Yeah,
to?
at the end of this lesson, in the reading, it does have it's set up for a greater than or equal to.
Okay.
Oh wait, that's if NP. Dang it! So I don't know. NP is greater than or equal to. I think we should be able to.
Yeah, I think we
Wait.
should be fine. Even if, what if we even did, Coke products are greater than or equal to Pepsi products, and then our null was just Pepsi products are greater than or equal to. I mean, it's pretty close because if they equal out, then it's, I guess it's kind of like the same hypothesis.
Right. What if we just made it greater than? I mean, because if we ended up finding out that people like it's pretty evenly distributed, then, you know, okay, with our hypothesis, the way that's set up, there wouldn't be enough data to support our alternative, and we would fail to reject the null.
Yeah.
Mm-hmm.
Okay. Okay.
So Coke product is greater than Pepsi product?
Yeah.
Is our null. So our null is Coke products are greater or liked by more people than Pepsi, and then our alternate is Pepsi products are liked by more people than Coke.
I like that. That's good.
Okay.
Pepsi products are what? Sorry?
Liked by more people than Coke products.
Oh. Okay, so we have to fill out who's doing what. Is that right? When I'm reading?
Right.
Did we already discuss that?
No, we will beyond that. I'm going to design the study. No, not really.
Okay.
So who wants to do? The weird part is there are 5 parts that need done as well. And so one person is going to do 2 parts.
2 parts?
Yeah, because so there's a step 1. So the designing the
Well, I
study
just
is
feel like-
one.
Well, I know the PowerPoint presentation is one. I feel like that's a pretty big one for just one person to do.
That's true.
Well, and it says that we can kind of blah, blah, blah. We can disperse the work as well. So like different people can do different things.
Yeah, we
But I
can.
was wondering, so would make inferences and take action go pretty well together?
Hmm.
That's true.
Because that might be, I mean, if we're talking about it, then it might not be too hard of a thing for the person doing the making the inferences to also take action. I
Yeah.
don't know what action we're going to take because of finding out if people like Coke products or Pepsi products more, but we'll figure something. We're going to suggest that all major sellers of soda switch, or like restaurants switch to one or the other. So if Pepsi products like more, Naomi, you might be switching to Pepsi products at work.
Gross. I don't want that.
Okay. Yeah, so I'm down.
I can help with the PowerPoints.
Yeah, I say we all like help with the PowerPoint.
Okay.
And then honestly, I'm fine. I'm fine with any of the other ones. If I need to take two, I mean, I should be okay. It honestly, if all the write-ups are just like this design to study, we pretty much got that done in this little group thing.
Right. It'll just be going through fine-tuning it and then running it by you all again.
Yeah. I honestly don't think it'll be that big of a project to be the main writer. We just got to make sure we coordinate it as a group.
Yeah. Well, in doing it like this, I mean, if we, in our first meeting of the week, we can talk about it, say what we're going to do, and then,
Yeah.
like, Thursday, I'm going to have that ready to show you guys.
Yeah.
So
That'd be
makes
sweet.
it easy.
Yeah, that sounds great.
Okay. So then, I guess, Tyler, do you want to do the describing data part then?
Great.
Okay, Joe or Naomi, do you guys have a preference?
I don't care either
No.
one.
Okay.
And then
I'll,
we can all work on the PowerPoint presentation together.
Yeah, I think, so Naomi, do you want to be like our main writer for the PowerPoint? But
Sure.
we can all take different parts on that, and then just send you the slides as we go.
Yeah.
Okay. And then, Joe, how do you feel about doing 2?
What was that?
Would you do step 4 and 5, Joe?
Yeah, I can do that.
Okay. Because this could go together pretty well, and as long as we keep in communication and we can do it together like this, it'll take no time at all. Yeah.
Yeah, it'll be good.
Sweet.
Okay.
Sounds good. I'm pumped. Yeah, if we do super good on this group project together, that'll really help our grade. I think it's a pretty good chunk of our
Oh,
grade.
yeah.
10% of the grade, guys.
What's that?
The group project is like 10% of the grade.
Oh, really?
That was it really?
Yeah.
Didn't you just barely say like 5 minutes ago that it wasn't a big part of our grade?
Isn't 10% not a big part?
That's a pretty good portion of it.
Well, it's divided into like 7 portions, though. So if you take that 10%,
Yeah, overall, I mean, it's not the biggest portion of our grades, but
the
Yeah.
exams are 60%, and there's only 3 of them.
Holy
yeah,
cow.
true.
So, I mean,
So it's 20% per each exam. Yeah, that's a lot.
When's
How
it-
much is the final worth? Do you know?
I have no idea.
Or do we have a
looking-
final?
We have a final in like the sense of there's a final quiz. I think it'll be just like a normal exam, and then we have the final project.
Interesting. Okay.
Sounds good. Yeah.
Oh, so we have 2 more exams. We have exam 3 and exam 4, and then it's done.
Okay, so yeah, there's 2 more.
Okay, sweet. Alrighty, well, I have a flag football game here soon that I thought they were going to cancel. So we might need to jump into the quiz if that's okay with everyone.
Yeah, I was just gonna say actually we should do that.
Okay, sweet.
All right, opening.
All right, so we're just gonna start the quiz.
Yeah, let's do it.
Okay.
Boom. Okay. So number 3 says, in a pie chart, why are the slices, sectors, different sizes? I had down each slice represents a category, and the area of each slice represents the proportion of the total occupied by the category.
Yeah.
All the
Yeah.
other options are pretty bad. Sweet.
Yeah.
So for how are bar charts and Pareto charts related? The only difference between a bar chart and a Pareto chart is that Pareto charts are organized from like largest to smallest, going left to right, which
Yeah.
I think is kind of cool because it makes them. You remember like our curves? They're totally
yeah.
right skewed.
Yeah, that's what they look like, huh?
Mhm.
Sweet. Yeah, I agree.
I'll do P, not 5. I think 5 is the one I didn't get actually. Is P the true proportion of the sample proportion? And I'm saying yes. Or no, sorry, no, it's not a yes or no. It's a sample proportion.
That's
Is that
what I
correct?
had too.
Yeah, that's P hat is what that's called.
P hat. Okay.
Yeah.
So that is the
Alright.
sample proportion?
P hat is the sample proportion, and then P is what that's taken from. So yeah, it's kind of like the difference between was it X and X bar?
Oh yeah.
Yeah, X is like the overall or the exact that we're using, and then X bar is the average.
Oh,
But
so
because the two are so closely related, we just use the same number.
so P hat is the true proportion, but just P is the sample proportion.
P would be the true proportion. P hat would be the sample proportion.
Oh, so P is the true proportion.
I thought that's what because it was like X and X bar.
So then that would mean 5, because 5 is asking for P, not P hat.
I'm suddenly not sure about my life choices.
In the reading it says if the sample size is large, the sample proportion, comma, P hat, comma. So does that mean that's the sample proportion?
So yeah,
P hat?
so P would be the true proportion.
Oh, okay. Oh yeah, that makes sense.
Yeah.
So P hat is the sample, P is the true proportion. Because we always take a P hat of P, right?
Yeah.
Awesome, got it.
So then N is a sample size.
Yep.
No
That's
way. Just kidding, I agree. Okay, 7, if P is 1/4, what is the smallest N that satisfies the requirement? I had 40. Because, I mean, if you take the very first one, N times P is greater than or equal to 10. 40 times 1/4 is exactly 10. And I guess you can't go any lower.
Right. Okay.
Okay.
For that,
Sounds good.
using that same comment to answer 7.
Yeah.
Okay. Well,
It's kind of weird though, because you use it in the other equation, and it adds up to like 30 or something like that. But
yeah, it would add up to a different number because the equation is different.
yeah. But yeah, that's what I came up with.
One thing that I'm curious, so we conclude that NP or P hat is normally distributed if NP is greater than or equal to 10 and N times 1 minus P is greater than or equal to 10.
Oh, that's a good
Remember
point.
if and is supposed to be an inclusive or an exclusive type of thing. Normally it's inclusive.
Yeah, I think that's a great point. I think it is because Or else it would say or.
Yeah. I know, like, in logic, in inductive logic, if you're doing that and they say and, you have to have both to meet the requirements of what they're asking.
That's true. So we would need to use, we would start with that second one then. So
Yeah.
1 minus. That is a great point.
So 1 minus 1/4 is going to be negative, or is going to be 3/4. What's the smallest that n can be?
Wouldn't that be...
But it also has to meet the requirements of the other one, so it's actually going to be a larger number.
Yeah, it is going to be larger. So 3/4 times by 10. Ooh. Oh,
So we're going back to number 7, though, right?
yeah, we're on number 7.
Yeah.
It's like right around 13.3 or 13.4.
We could just put 40 over thirds, 40 over 3.
Is that what the answer is?
I mean, 13.3 is 40 over 3, so...
Well, but does 13.3 meet the requirement for the other one as well?
Yeah. Oh.
Which is why I think it's going to end up being a larger number than 40.
Really?
I think so, because
Because when you
if
go
40 is
1
the
minus...
smallest that the other one can be, and it still doesn't meet the requirement for n times 1 minus p.
has to go bigger.
Yeah, I mean, I'm thinking, what does 44 look like as n?
Yeah, that's true. One minus 0.25 equals times by 40. 30. Wait a minute.
What?
No, 40 still does meet the requirement.
40 does?
Yeah, because when you go 1 minus 0.25, that equals 0.7 times, and then you times it by 40.
You get 30?
Yeah,
Okay.
which is greater than 10.
Yep, okay, cool. I'm good with it then. 40 works. Woo!
So then, yeah, 40 times by 0.25. Okay, yeah.
Where do really short questions come from? Okay. So number 8, use the following information to answer 8 and 9. Suppose n equals 24 and p equals 4. What is the mean of p hat? So p hat in this case is going to be the same thing. It's going to be 0.4. And then the standard deviation will be p hat over the square root of n.
Nice. You kind of froze up there for a second. So 8 you said 0.4, and then 9 is 0.01?
9 is going to be the formula for the standard deviation of p hat is p hat divided by the square root of n.
Mm-hmm.
So p hat is going to be p, the same thing.
Yeah, 0.4.
Yeah, and then this standard deviation from what I got is going to be, rounding 3 decimal places, 0.082.
Isn't the oh whoa. Since we're working with p, isn't the standard deviation formula, it's p over 1 minus p over n, and then you take the square root of all of those?
Yeah, that's what I thought.
It might be. I might be thinking of something different.
Here, let me. Yeah, that's. I don't think I ever took the square root of that though. So it would be let's see, 1 minus 0.4 equals, and then you would times that by 0.4, and you divide it by 24 equals 0.01, so it's square root of 0.01.
And you got
0.1.
0.0001?
Is that what you got?
Yeah.
I got point 1.
Yeah, I got 0.1 too.
Hmm.
Wait, so what is the square root of 0.01? Square root? Yeah, I think it's. Yeah, it is. 0.01 square
Oh,
root.
you know what? I did it wrong.
0.1.
I did it wrong.
Sweet.
Okay, yeah. 0.1.
So
I got
9.
that too.
So 8 is 0.4, 9 is 0.1, right?
Yes.
Sweet. Okay, who's got 10?
I'll do 10. Use the following information to answers 10 through 13. Brittany's batting average is 300. We want to determine the probability she will get more than 35 hits in her next 100 at-bats. N is equal to 1, P is equal to 0.3. So the probability, let's see.
So we got all the formulas.
Let's see, probability. All right, so you just take the z-score minus, you take the z-score of it, right?
Yeah, how do you find a p-hat again?
Good question.
Or is p-hat the same as just 0.3?
I thought it was from what I remember in the video. But it's
I think
asking
it
us
is.
about 2 decimal places, which makes me really unsure about it.
That's true.
I hate it when they do that. They're like, hey, you're so confident. Let me just ruin that confidence. Rah.
Yeah, because it says the mean of sample proportions, the mean p-hat is equal, but it's like it switched it around. No way, that's totally it.
What?
I think it is 0.3.
So
It
the
says that p hat is equal to x over n.
Oh, really?
yeah,
Like in the
there we go.
reading.
Oh,
Wait,
yeah,
what is
that's
X?
true. Is x 35?
It would be 35 over 100.
Yeah. Uh-huh.
Oh, yeah.
So, so it would be 0.35 over 3, so it would be 0.35 minus 0.3 over the rest of it. So
Wait, is that p hat? Or the standard deviation of p hat?
P-hat is just x over n, right?
That's what it says in the reading.
Yeah, no, I remember that. We just got to figure out what x is. Next few ones are going to be super easy.
Wouldn't it be 35?
So,
N's 100.
Where
We-
X is the number
average.
of individuals with a certain characteristic.
we want to determine the probability she will get more than 35 hits in her next 100 bats. So since it's 0.3, don't we just need to find the decimal of 35 out of 100? So 35 divided by 100. Yeah, it's just 0.35. So x is 0.35. Over divided by 100. So I think it's just point. round that to the nearest 2 decimal places. What the? Because it's originally saying that her batting average is 0.3. So if we wanted to determine if she will get more than 35 hits in her next 100 at bats, 35 out of 100 is 0.35.
Mm-hmm.
Right.
Is it X over N or N over X?
It's X over N.
Yeah.
0.35.
So yeah, it's going to be the 0.35 then.
0.35. But 0.35 divided by, how do you do that? 0.35 divided by 100?
Well, it's going to, so X is 35,
Mm-hmm.
and so X 35 over N 100 is going to equal 0.35.
It just equals 0.35?
Yeah, so P hat would be 0.35.
Okay, that makes sense. So when you have a decimal over, when you go 0.35 over 100, that always just equals whatever's on top?
Pretty much, yeah.
Hmm.
If you have anything over 100, like, it's the same concept with multiplying by 100,
Mm-hmm.
except for, like, with dividing, instead of moving the decimal to the right, you move it to the left.
Oh, yeah, because then it's just 35 divided by 100 again. Okay. So then, what is the standard deviation of p hat? This
I got
formula.
0.046.
Oh, nice. So it's 0.31 minus 0.3 equals times by 0.3 divided by 100. What did you get?
0.046 rounded.
Yeah, I got 0.046. Yeah.
Okay, cool.
What number is this?
11.
11. I got, for my standard deviation,
Yeah.
I got 0.021.
Really?
So it would be 0.3 times 0.7 over 10, right?
Right,
Over
and then you take the
100.
square root of it.
Yeah, so
And n is 100.
yeah, so it would be over the square root of 100. Yeah, so it would be 0.021 over 10. Or no, 0.21
Well, it's
over
not
10.
over the square root of 100. You do
Yeah, that's
p times 1 minus p divided by n, and then you take the square root of everything.
Oh, that makes a difference.
It's a little bit different.
Yeah, that makes a big difference.
So then the z-score, we take 0.35 minus 0.3 equals, so that's 0.5. And you just divide that by that same answer that we just got, right?
Right.
So for a z-score, I got negative 0.254.
You got negative?
Yeah.
I got a positive answer.
You did?
Did you take p hat minus p?
Yeah.
And then
0.35.
divided by the square of...
I just divided it by 0.046, which is our standard
Right.
deviation of p hat.
You do 0.35 minus 0.3?
Yeah.
Because you should have come out with a positive answer.
0.35 minus 0.3 equals... Oh! And then, yeah, so it's 0.05 divided by 0.046. Oh, so did you get 1.087?
Yep.
Oops. And then we need the
And then the probability, I'm seeing a probability of 0.1385. 0.39.
Yeah, that's
Because
what I got.
she's wanting get more than 35 hits, so we're highlighting all things to the right of our upper bound z-score.
0.139.
Mm-hmm.
Sweet.
Okay, can I run this by you guys one more time? So our standard, the p hat is 0.35. Our standard deviation is 0.0. I've got 0.038, but I know that's wrong.
It's 0.046.
46. Okay, sorry about that. Okay, z-score was what?
1.087.
And then for the probability, it was 0. Let me plug that in.
139.
139. Okay. 0.139. Okay, cool. Thanks.
True proportion of people who support. When to determine the probability that the results of the survey will suggest getting less than 50% of the votes. What is the standard deviation of P? So we know that P is so 0.52 1 minus 0.52 times by 0.52 divided by 2. And take the square root. Wow. Did you guys get 0.011?
For
Hold on.
14?
Yeah.
I haven't even calculated p hat yet.
Oh, that's right. Oh, do you need to calculate p hat to get the standard deviation?
I thought you did.
I don't think so, because it's just the normal p and then 1 minus p over n. Square root.
Okay. Then yeah, you wouldn't. You do need it for the z-score, though.
Yeah, we'll need it for the z-score. So yeah, if I did that right, let me do it one more time. 1 minus 0.52 goes times by 0.52 divided by 2,000 square root. Yeah, 0.011.
Yeah, that's what I got. 0.011.
Yes.
For
14.
I got 0.0001.
Really?
Yeah, let me try it one more
Well,
time.
did you square root it though?
What?
Did you square root
yeah, you
that?
gotta square root it.
Oh, I didn't. Okay. Thank you for reminding me.
Mm-hmm.
So 0.011.
Yeah.
Good deal.
What z-score would you use? So that's still the same thing, x over p, right?
The z-score?
Yeah.
The z-score is like the p bar or p hat minus p over
sorry.
standard deviation.
I meant the p hat. P hat is x over p, right? X over n.
Well, okay, so
Yeah.
in this case,
Isn't p hat just 0.5?
what?
Isn't p hat just 0.5?
No, because 50% is 0.5, and so that's going to be our x, and then we would take
Divided
x
by
over
2,000.
2,000.
So it's 0.00025.
That's 15.
Yeah.
Wait,
Minus.
no. I'm just trying to figure out the p hat still.
Oh, gotcha.
Because it's hard when you get
I got negative 4.725 for a z-score.
Did you already get the z-score, Dylan?
I think so.
What did you get at?
For the z-score?
Just for p hat, the x over n. What does that equal?
I took 0.5 divided by 2,000.
And you got like 0.00025.
Yeah.
Can
It was,
you take a decimal divided by something?
I'm suddenly not sure. No, you wouldn't be able to.
Because if that's the case, then our p hat would be different in that problem that we did above.
No, how would our p hat be different?
Oops.
Because we could have taken. Couldn't we have taken like 0.35? It would be 0.35 divided by 100.
Well, no, because up above, so where am I looking at? Up here we took 35. So we wanted to determine the probability that she will get more than 35 hits. So we took 35 and then divided it by 100 to get 0.35 in the first place. There was no decimal to start with.
Oh, really?
Yeah.
Oh, okay. So I was looking at that different because it says Brittany's batting average is 0.3. And so I figured since it gave us she'll get more than 35 hits in her next 100 at bats.
Right.
I took 35 divided by 100 right there, and then I called that our X. So I was thinking 0.35 was the X. And then it
0.35
was,
would be the p hat in that case.
would it?
Yeah. Which is why I think 0.00025 would be our p hat right now. Minus 0.011, 0.05, or 0.52.
Because 0.5.
Divided by 0.011. But you're right. Technically, you can't divide a decimal normally. Or like if you're doing math by hand, you normally don't.
You can't?
But well, normally being when you're learning about that stuff, they generally don't do it. So I'm wondering if we took 2. No, because the alternative would be doing 2 times 2,000, which I don't think would work near as well.
Right.
For our p hat. So I think we're doing the 0.5 divided by 2,000, then minus. I've gotten a different answer every time I've done this, and it's kind of starting to throw me off.
Are you doing the z-score right now?
I'm trying to, yeah.
What did you get for the z-score?
Did you get the Z-score, Naomi?
Well, I think it's wrong because it's really high. Well, it's negative 47.25. That's what I got.
Oh, really?
I don't think that'll be right.
I just got 0.023 twice in a row. That's the first time I've gotten the same answer twice doing this. I want you to know that. It's a significant
Really?
event. Yeah.
Okay, I'm just true proportion of people.
Yeah, I just got the same thing as Naomi, though. Negative 47.25. I don't know what I was doing differently just now. My brain is not working anymore. It just failed me. Yeah, I agree. I don't think we're doing something right.
So 14 is not right, huh?
Yeah, and the problem is that I'm worried that we might not actually have gotten the right p hat up above earlier.
If a coin is tossed.
So one thing I just remembered. I wonder if it would hold true here as well. Oh, never mind.
Oh, the p hat is just. Yeah, the p hat is just 0.5.
It is?
Yeah, I was looking in the reading. The reading is pretty much giving the exact same equation in 3.3.2. it's saying to address this question, we first need to note that the survey will suggest that the candidate will win if more than 50% of the people surveyed favor the candidate. So we need to find the following probability. P is P bar greater than 0.5. First we find the z-score, and then they use that as their P hat, just 0.5. And it's like set up exactly the way this question is.
So then I wonder, did we get our P hat up above wrong as well?
No, we actually did get that one right.
Okay,
Because
so it's just...
Yeah. That in that example, it just took 35 divided by 100.
Okay, so it's 0.5 minus 0.52 divided by 0.011. I got 1.818. Negative 1.818.
0.5 minus 0.52.
What probability do you want to use to compute the...
Wait, what'd you get, 15?
We're going to use less than. I got negative 1.818. Is that what you guys got too?
I'm still working on that one.
Yeah, hold on.
Negative 0.02.
So wait, P bar is 0.5 minus 0.52 divided by 0.011.
Wait, what did you get?
Negative 1.818.
1818. That's probably right. I just have this stupid little calculator.
What did you do? So, what did you say that you had gotten?
I got negative 0.179, but I just think that's because of my calculator. Let me just write it down real quick. Because it's just 0.5 minus 0.52. So it's a negative 0.02. And then P, which is 0.1 minus 0.52 equals times by 0.52 equals divided by 2000 equals, and then you square that. So yeah, then that becomes 10.
Okay, yeah, I got negative 1.818.
So yeah, then it's negative 0.02 divided by 0.0111. 7139. I'm still getting negative 1.79. That's weird.
That's interesting.
So just to walk through it really quick, you just did 0.5 minus 0.52, right?
Yeah.
And then you did 0.52, or yeah, 0.52 times by 1 minus 0.52 over 2000 square root, and then you divide the both of them.
Yeah.
Yeah.
Well, yeah.
So you get negative 0.02 divided by 0.011.
Yep, 0.1117139 or whatever.
So you
Because
get?
when I compute that on my computer or on my calculator, 0.0111.
I still get negative 818.
Oh really? I guess when I just do when I do it by 1.11, I get that answer. Because I can do negative 0.02 divided by 0.011. Yeah, then I get negative 0.18181. But when I have, this is crazy. Because when I have the entire number, do you know how it comes out to be like 0.0117139 or whatever?
Oh, yeah.
Right.
Yeah, when I give that whole number, then it comes out to be 0.79 or whatever.
Right. Well, and I threw like an extra 1 into mine when I did it again, and I got a z-score of negative 1.801, 801, 801, 801, repeating everything.
Oh, really?
So I think that's just a matter of rounding, and they probably have that factored in, because the difference was like 0.001 after I rounded. So like what I got for a p-score, with negative 1.818 was 0.035 after I rounded, and then with the negative 1.801 after rounding, it's 0.036.
Oh, really?
So I think it's just they probably have it like, okay, there's a certain range because everybody's going to round differently, doing this to 3 places type of thing.
Okay.
That's my thought on the matter, at least.
Yeah, I agree with that. All right.
So then what do you guys think, number 16? I said P, Z less than or equal to Z.
Okay, let me plug that in real quick. Equals. So then our probability is 0.0367 or something like that.
See, and that's where I got 0.035 for the probability.
Really? Oh, I see.
Yeah.
So since our p-value is... Oh, we don't even have like an alpha or anything to compare it to.
Right. Well, that's why. What probability do you compute using the normal probability applet? I said P large Z less than or equal to little z.
Less than or equal to?
Yeah. Because it's asking getting less than 50% of the votes.
Oh, yeah, that's right, huh?
Mm-hmm.
So that's the original question, is less than.
Hmm.
Less than 50%. And we definitely got less than 50%. We got like 3%. So there's a 3% chance that she would bat more than that.
Right.
Or sorry, not bat, but that she'll get voted.
And then you guys got 0.035 for the probability?
Yeah.
What is the probability the survey results will show the candidate? Even though the true P is 0.52. Survey results will show the... So that's just our p-value. That's exactly what we got. What is the probability the survey results will show the candidate is losing?
Yeah.
So it's just our... Wait, so what did you get exactly?
For my probability?
Yeah.
0.035.
3.5.
Yeah.
Man, I hope they have that. I hope they have that like factored in the way that people do their rounding.
Right. Well, I submitted our score, or I submitted the test, and we missed one, but I don't want to tell you guys what it is. But I think it is one because, like, it's one that we got a later question right that was completely dependent on it. So I think it was rounding that did us in, but it happens.
Okay. So real quick, before I just want to run over it because I feel like I've kind of been behind. Like I get behind at one point and then I miss like the next 3 questions. So number 14 was 0.011, or is that incorrect?
What's that?
Number 14 was 0.011. Is that correct?
Yeah.
Okay, and number 15 was negative 1.818. Is that correct?
Yeah. And then
Okay.
what should I submit the one that I got to see if we get a different answer? Because for when I originally did it, I got negative 1.790. But I guess, no, just kidding. I'll just put what everyone else puts. So negative 0.181.
Or negative 1.818.
Yeah.
Yeah, okay. All right. Yeah, we'll just have to check that out later on.
Sweet. Alrighty, anything else? I think I might have to jump off and shoot up to the fields.
No worries.
Is everything
Do we have to
all
submit
good?
everything individually tonight for the group submission, or do we have to, or is one person submitting it enough?
What's
There's
that?
nothing to do tonight, but when at the end of the week I'll submit for the design the study. Only one person needs to submit that.
Okay, so we just go online and say that we, like, you click this mark activities done. Is that what you do?
Pretty much, yeah.
All right. Sounds good.
Cool. I guess we're done.
All right. Sounds good. Appreciate it.
No problem.